here we want to find the limit of x to the 1 over x as x approaches 0 from the right. And so we let x approaches 0 from the right, and we get a 0. And then this is 1 divided by. Now, as x approaches 0, meaning for the 1 over x, the denominator is getting smaller and smaller and smaller and smaller. And so 1 divided by something that gets smaller and smaller and smaller towards 0, positive. And then this will be infinity. And so we have the indeterminate form of 0 to the infinity. And so it's not 0 over 0 or infinity over infinity. And therefore we cannot use L'Hopital's rule. And so we have to use another strategy. And so what we can do is let y, this whole thing right here. And then take the natural log of the left side of both sides, and we get a limit of this. We have a theorem on limit of composite function, and it says that we can rewrite this right here as this. This is the same as the limit of ln of x to the 1 over x. So this is the theorem on limits of composite function that allows us to bring the limit to the outside. And this right here, this becomes, since we have natural log of x to the 1 over x, then we can write this as 1 over x ln of x. And then this becomes ln of x dividing by x. For this particular problem, let's go ahead and rewrite it like this so that we can get our limit. And this is the limit of a product. This is product of limits. And so notice right here, as x gets smaller and smaller and smaller, 1 divided by x will approach positive infinity. And then for ln of x, as x gets smaller and smaller, ln of x will approach negative infinity. and then positive infinity times negative infinity is just negative infinity. And so now we have ln of y is equal to negative infinity. And as we notice right here, as x approaches 0, that's a mistake. So as x gets smaller and smaller and smaller towards 0, and remember that log of a negative number is undefined, and so that's why it has to approach 0 from the right. So x has to stay positive. And this will approach negative infinity. And so the same logic will work here. The only way that ln of y can get to negative infinity if y is approaching 0 on the right. So then y has to approach 0 from the right. So one more time, in order for the quantity ln y to approach negative infinity, y has to approach 0 from the right. But y is this, so y will go to 0, and therefore the limit y is equal to that limit, the limit of x equal to of x to the 1 over x, and therefore this limit right here has to be 0.